All right, Sarah.
Oh, hey. Clicky thing.
Stole the clicky.
Yay, thanks, other Sarah.
So you decided to pick
yeah.
detection of dynamo waves inside the sun.
Right?
Dynamos.
Dynamos, because...
It's a powerful topic there.
Yes, we like energy. But all right.
So what's this all about?
That is about what's going on inside the sun and how it splurts out to the surface. That's right. This is the sun. This is the sun on sunspots. Any questions? All right, so what are sunspots? Sunspots are electromagnetic storms in the surface of the sun. You get these magnetic field lines that get all tangled up. You can see that here. So the Earth is mostly a solid. It rotates as one body, but the sun is a ball of plasma, and so it's, electrical goo, right? And so you get the top bit rotating more slowly than the equatorial bit, so you're stretching these electromagnetic field lines all the way around, and they stretch and stretch and stretch. And eventually, they get all bound up and wound up, and they start snapping. And they snap to the surface, and we call those sunspots. All right. What's some stellar indigestion?
Solar indigestion.
Yes. Blurp. All right. Now, we have been tracking sunspots since Galileo. So we've got a 400-year record of how many visible sunspots we could observe. We are filling in this end over here with more tools than just looking at the surface now. We can look inside. Now, this is helioseismology.
So if you blur your eyes, it's supposed to be 3D.
Yeah, can you see the dolphin? No. All right, so what we're seeing is sound waves traveling through the core of the sun, well, through the atmosphere of the sun, out to the surface, and then we can measure how the Doppler shift of the surface, the churning granules on the surface of the sun, if this bit's coming toward us, this bit's moving away from us, and we can kind of extrapolate backwards and build an image of the center of the sun.
People like to say the sun is ringing like a bell. Like if you strike a bell, it rings and has certain modes in it. The sun does the same thing. It vibrates in certain oscillations, and that tells you about what's going on underneath.
Yeah.
So.
And that has allowed us to model this. Now, this is one of the solar cycles. So the sun cycles over 11 years, 22, but that's a different story. So it's got a peak of sunspots and a dearth of sunspots. And so we are looking at this right here. We're looking at the beginning, or the peak of 23. But because we can model the interior of the sun, we can see the beginning of 24. And that's what this study was. They were basically proving that this right here does become this over here. All right. So we can watch it happening because they built us a model. All right, so if you watch right here, you'll see this churning underneath, and then eventually it'll push this right down here, and this is the sunspot activity. So you get cycle 24 happening over here while 23 is happening here, and it...
So you're saying the vibrations on the surface can tell us what the magnetic field is doing underneath, and that can tell us what the next cycle will do.
Yes.
Do you believe this?
I do, because science. I mean, no, I don't believe it. I understand it.
Excellent.
All right, so instead of this, which gives us lovely desktop images, we can look forward to this. Wow. Which is actually really great for humans on the surface of the Earth, despite being protected by our magnetic field ourselves, because we have satellites, and we have astronauts, and we have power grids. And so a calm sun like this means we're not getting blasted and irradiated by stuff that can damage our tech.
Which is a good thing.
Yeah.
We will have sunspots. It won't be
course.
blank the entire time, but it won't be like sometimes we have tons and tons of them. So very interesting. We'll see if this holds true and continues to. I think it might, because we understand it. Anyway, thank you so much, Sarah, for doing this.